So I'm Mike Vetter. I'm going to be your entertainer for this morning. So I want to thank Arkwin Industries for coming out and supporting. They'll be available for questions if there's anything afterwards, but you're going to get my pitch on manufacturing careers, go through some of the different, what East-West does and also some of the careers available here. And then, speak more broadly about manufacturing and engineering, because I'm an engineer by training, if I don't get to do so much anymore, though, but that's okay. So we're here for the Career Conversations event on STEM Hub. So it's my beautiful face there. I'm the Senior Director of Product Development at East-West. So went to Nassau, finished up at Rutgers University in New Jersey. I have a bachelor's in mechanical engineering, graduated in 2005. I've been at East-West ever since. So I started as a design engineer, worked my way up through the company, and now I'm in charge of design and manufacturing engineering as well as the business development team. So I've been doing that for a couple years. Some background in East-West. East-West is an 85-person woman-owned small business. Been in business since 1968, and I'll talk through some of the product lines and more detailed roles that we have there in a little bit. So, manufacturing. Talk about some high-tech technology like socks, right? You go, socks, it's just a thing, right? But yeah, when you think about, and I know we've all heard this expression a lot the last couple of years about supply chain and what it takes to take, from the raw cotton all the way out to socks in your drawer, right? You've got to harvest the cotton, you've got to spin it into thread, you've got to weave it, got to package it, got to deliver it. And all along those different operations, there's employees, right? Whether you have the manual labor, the machine operators, the aesthetic designers, the industrial designers. There's a whole lot of roles that encompass all different skill sets all along that supply chain. So Oxford Dictionary defines manufacturing as the making of articles on a large scale using machinery. And so today I'm going to discuss what we do at East-West. So as I mentioned, we're a woman-owned small business located in Ronkonkoma, New York, a single-site business. So we have three major product lines, which is seating systems. So we do what's called crash-worthy seats for helicopters. So in this case, this is a Bell 505, a passenger helicopter, a 5-seat passenger helicopter. We do the back seats, so they're nice, upholstered VIP level seats with leather and all types of fancy plating on the seat buckles and all those things you see like in a private jet, but just in a light helicopter. We do military seats, so we do seats for the CH-47 Chinook. The gray seat on the right is a gunner seat for the HH-60W combat rescue helicopter, which is what flies out of, anybody who's familiar with, out in West Hampton at Gabreski Airport. There's 106 Rescue Squadron. It's an Air National Guard squadron. They fly that helicopter, and their motto is so others may live. So they literally, every day, they go out and put their lives at risk to go rescue someone. I was reading about a mission they did where they actually landed a couple of their combat rescue, para-rescue jumpers on the deck of a ship. There had been an accident in the engine room, and this was a civilian ship, but they flew from West Hampton out to the Azores, basically halfway across the Atlantic Ocean, got guys on the deck and saved two people's lives who were very badly burned. Obviously, the primary mission is to go rescue downed airmen, but they do a lot of civilian and compassionate work as well. So really key asset for the U.S. Air Force. East-West designed, qualified, and now builds two different seating systems for that aircraft. And this is for the E-2D Hawkeye. I think there's an E-2D. They're working on getting one restored here. So we do the pilot, co-pilot, and operator seats. The E-2D aircraft is a carrier-based aircraft. It's a propeller. It's the last propeller aircraft on the carrier deck, which gives a lot of interesting requirements for the seat design because we have to design for vibration, long endurance. This aircraft can now be in-flight refueled, so you can be in the air for up to 8 hours at a time. So obviously you're in a very cramped environment. I know for a fact there is an E-2D cockpit in the exhibit hall next door. It's a very cramped environment. You can't get up and walk around really, so we have to design the seat to be as comfortable as possible. So we have a very long list of structural requirements. The seat has to be able to take a 20G what's called a trap, landing on the carrier, a 30G crash. But you also have to incorporate, in this case, their parachute, all the adjustments for the seat, and also make it as comfortable as possible while sitting. All of you who are sitting in these seats right now, even 20, 30 minutes, you might start fidgeting, getting uncomfortable. We have to do that for 8 hours. So very interesting design engineering requirements, and that's where my team of about 15 people works to kind of balance the soft requirements for comfort, human factors, make sure that people of all different sizes, the U.S. military now obviously has people from, I've done fit checks with women who are 4'10" and 100 pounds maybe, up to people that are 5 inches taller than me, and the seat has to accommodate everybody. So that puts a lot of challenges in the design requirements, and then obviously getting them qualified. Another big piece of the business is ground support equipment. So we make a couple of different cranes to maintain the aircraft. So in this case, this is a crane we make for the Air National Guard, as well as international F-16 users. It also is used for the F-22 and F-35 JSF program. And basically with that crane, you can take wing controls, canopies, ejection seats, all types of equipment like that off the aircraft and maintain it without having a big overhead crane or more complicated. This is all manual operation crane. Another kind of our original product line was oxygen systems. So we make oxygen systems. On the right is a system that goes in that parachute that you saw in the E2D seat. So actually, if there's ever an emergency and they need to bail out, they pull that, no, I don't know where the laser is, but that green ball up there, they pull that, it turns the oxygen on. They can breathe while they're descending under a parachute. On the left is the survival kit for the F-18. So there will be a picture in a second, but basically in the F-18, when the pilot pulls the ejection handle, the seat pops out of the aircraft, and then the seat falls away, and all they have left is their survival kit that has their oxygen system, that has an emergency beacon, a life raft, their survival aids, first aid kit, anything they need to go and get themselves rescued, basically, and be able to survive in the field for a long time if need be. This is our newest system. This actually gives them up to an hour of backup oxygen, so even if there's a situation in the cockpit, there's smoke in the cockpit, their onboard oxygen system fails, they can breathe off this for up to an hour, which was a huge safety improvement because in the 2015 to 2020 timeframe, while there was still a lot of aircraft operating over Iraq and Afghanistan, they were having problems with their oxygen system, and the pilots were having to either return to base or get down low and breathe off air. So this system allows them to turn the system on. They can breathe up to an hour, at altitude, finish the mission, get home safely, which is a tremendous safety improvement. So we're fielding these now on the F-18. Just kind of a fun action shot. Anybody who's seen Top Gun Maverick, that is our survival kit that he's struggling to detach himself from. Note that's not our part that he was struggling with, but that's a government part. But the rest of the kit is ours, so just a kind of a cool, we're all, obviously, we're pretty lucky. We have a lot of former service members that work for us, so anytime they can see their products in a relevant environment is pretty exciting to them, so that was kind of neat. So the East-West factory, so as I think I mentioned, we're 75,000 square feet, all under one roof, and the factory kind of breaks down like that. So engineering, kind of my half of the building is about half. We have, like I said, 15 engineers. I have my quality department, some support areas for like prototyping and labs, administration and purchasing. We have an oxygen lab, which is an enclosed clean room type environment where we have special technicians who just work on oxygen systems because there's very high cleanliness and safety requirements for that. We have a machine shop where we make a lot of our parts in-house, an assembly shop, pretty self-explanatory, and then obviously some warehouse. We have a really large quality control area because obviously every part is very safety critical, so every part has to get inspected, measured, make sure that what's called the lineage, make sure that we can verify that from when it got made into raw material to when it went out the door, we know who touched it, where it was made, and then obviously we can trace it back. So if ever, God forbid, as I'm sure you all saw, the Boeing incident with the door, you can go back and pull all that paperwork and say, here's who did it, here's who signed off on it, here's who inspected it, and you need that chain of custody. So there's a lot of work that goes into verifying that throughout the process. So successful manufacturing, as much as I like to think the design engineering guys are the most important part of the team, we're not. It's more than just a good design. You need it to be delivered on quality, on time, at the best value to the customer. And it takes the entire team to do that. I mean, we've all heard, there's no I in team, all those things, but it really is, in manufacturing, it really is a team environment, because I've had projects gone wrong where the designers did a great job and it went to manufacturing engineering and they're a little lazy, a little slow getting things ready, and the parts come together and they don't fit. We've had times where the supply chain just doesn't support the customer's needs. The customer says, on that E2D program, we were lucky. They wanted to get us fielded on their production aircraft as soon as possible. So we're still designing and they're also ordering parts at the same time. And I'm pushing both sides to say, just buy what's on the engineering. Don't worry about what if. And it's a challenge. You have to have 20 people in a room all yelling at each other, but eventually you get it sorted out and you get the product built. And as I mentioned, it's as important to plan how you're going to build it as what you're actually building. I heard the team at Arkwin talking about additive manufacturing, conventional machining, castings, forgings. A lot of that work gets put in up front so you can understand what it's going to take to build the product, if there's any special testing or anything like that needed to certify it. So I'm just going to walk through some of the career fields now at East West. So obviously, it kind of starts at IT. Nowadays, cybersecurity is critical. It's probably going to be the biggest cost item in the overhead part of manufacturing in the next couple of years. Obviously in engineering, we use several different design tools, CAD software, things like that. And obviously it has to be cybersecure to make sure there's no foreign intrusion. Obviously our IP is ours, we own it, so we don't want someone to steal it. So protecting that's as important as anything else. IT varies, and obviously we have just the kind of tech help. My printer doesn't work, rolls all the way up to cybersecurity analysts who are going through and making sure that we're monitoring intrusions and making sure our systems are ready to meet the government requirements, which have changed annually for the last 7 years. So it's becoming a full-time job, just making sure that we're keeping up with the requirements that they have. So cybersecurity is a really important piece of what we do. Network design, making sure that when I put out a design in engineering, the inspection and manufacturing teams get that same design and can make it seamlessly without exchanging paper and everything else. So having those systems that do that's really critical. Design engineers, you kind of heard a lot about that. Like I said, we use CAD, we use analysis software. We do a lot of design by analysis and design by simulation. And then we go out for our product line. There's always that qualification step. So we have some labs on Long Island, some across the country. We actually will strap test dummies in, shoot them down the rails. Hopefully you don't break stuff. Hopefully it's a very boring test. I can't promise that's always how it goes. Vibration tests, anything that goes in a propeller or rotorcraft has to get tested for hundreds of hours of vibration testing to make sure that when it goes out to the fleet, it's going to be completely reliable. And we work in a team. Generally, it could be anything from a one-person team up to about a 6 to 8 people team, depending on the program, depending on the customer requirements, depending on the complexity of the design. My design engineers are all 4-year degreed people. That's just kind of a criticality because of some of the detail work we do. That's probably the one role in the entire company that you have to be a degreed person. Anything else, there is an opportunity, if not a preference, to be OJT, on the job training. So this is kind of a time lapse of some of the advanced design work we're doing. So this is what's kind of getting a trendy name of digital twin. So here we're taking one of our seats, we're putting a test dummy model that's fully fidelic, so it moves the way a test dummy moves, it responds the way the test dummy responds. All of the materials and the design you see in this seat is actually based on actual testing. So when you go into a virtual test, in this case it's a what's called a stroking test. So you can see the picture on the left, the gap between where that orange headrest is and that bar that goes across, it's at the top. And during the test, that seat strokes downward. That stroking absorbs energy, protects the occupant. We designed that attenuator system. It's a patented design. So we design it for the crash case that we're given by the customer. So in this case, we're doing some analysis to make sure that this is actually a small person in the seat. This is like a 50th percentile, so 5'9", 180 pounds with a, some ballast on their chest. And we go through and make sure that that seat can not just take the load without braking, but also protect the occupant, because we can measure, because everything is validated, we can measure what the dummy is seeing, and hopefully when they go and do the actual testing, those measurements are the same, and we can prove it's safe for the user. So this is a lot of work goes into this pre-manufacturing step. So I haven't made any of these parts, but I've ordered all these parts. So I have to trust that this analysis is right, because I'm buying parts a year before I actually make and go do the actual testing. So getting it right the first time is really critical. Manufacturing and industrial engineering, again, they're part of my team as well. We're all in one office, because what tends to happen as the designers are finishing up the project, they're handing it over to the manufacturing engineers. So they're working on, sometimes they're 3D printing prototypes to give to the machine shop. Sometimes they're making tooling. Like this picture in the center is kind of a assembly fixture for the survival kit for the ejection seat. It allows them to build it without having to move it around and possibly risk damaging it. Sometimes there's fixtures that we use for assembly, drill jigs, things like that. And so they're working on all that hard tooling, or sometimes just the paperwork trail and the assembly instructions to make sure that when the parts get in the shop, they're ready to go right to the floor and get built. There's also a lot of documentation and business software to make sure that we have the right bills of materials, we're ordering the right parts. If a part needs some special process and finish, like paint or lubrication or something, it goes out through the supply chain and comes back ready to be assembled. Production planning and purchasing. So this is the team that, I give them a drawing. I say I need, a bill of materials that says I need 10 of them. They go out, they get quotes. They work with the supply chain to make sure we're buying parts from the best value vendor that can actually deliver the parts on time, on quality. Production planning is making sure that the parts are on time when we need them to build it. If I have 99 out of 100 parts on the day I need to build it, and I have that one part, I can't finish the product. I can't deliver to the customer. So making sure that everything's planned out so we have it when we need it in the production process is really critical. Obviously for this, it's a little bit of math, a little bit of just communication and teamwork skills, a little bit of problem solving. And most of our planners and purchase people are high school graduates. We do have some business people, but for the most part, it's definitely a lot of people who have just been doing this for a long time, and it's on-the-job training. The picture on the bottom is just a typical trade show that I'll attend, or I'll have some of my team attend, and we'll go through and meet new vendors, meet new suppliers, and build those relationships that result in us getting good quality parts. So machine shop, East-West, I actually just pulled this stat the other day. We have about 7,000 individual part numbers. We probably make about 5 or 10% of those in-house or have the ability to do so, but we do have a core capability to machine parts in-house. What you see there are 2 of our CNC machines. These are what's called 3-axis or 4-axis machines, where we can actually machine pretty much any part using different machine tools, different fixturing. So a lot of times when we're prototyping a job, we'll have the in-house machinist do all the machining, make lots of chips, as we call it. They'll take a piece of stock that might weigh 10 or 20 pounds, end up with a part that weighs 1 or 2. So there's a lot of material that gets used up, and then we recycle that. And that's kind of fun. When I was a young designer, that was my favorite place to hang out, was the machine shop, because it goes from that, you're looking at your monitor, and you spend hours, days, weeks designing a part and obsessing over every little feature, and then you finally, you give your drawing, you're so proud, you walk down to the machine shop, and they usually make fun of you, but once they get you the part, you go, that's it? That's what I worked on for all this time? But it's really rewarding when you see that part come to fruition. Very much, this is absolutely core to our team. It's a skill set that we're really struggling to fill. And I don't think I have any GEDs, but it's definitely, we do have a career path with Suffolk Community College, taking people directly from high school and placing them after a quick training period placing them in the machine shop, and it can be a very lucrative career, and I think very rewarding. I have a core team of guys that have been there for 15 years, some of them, and they may be a little cranky in the mornings, but they do enjoy what they do. Anybody who's ever worked with a machinist knows that's a 100% factual statement. But assembly, so again, we have a kind of a variety of parts. We have parts that are built under microscope, as you can see, very, very tight tolerance, clockwork type parts, all the way up to our crane, which is 2,000 pounds, and really big, big tools to assemble it, cranes to lift the parts, things like that. So there's a pretty big variety of products at East West. We do use apprenticeships for on-the-job training. We try to cross-train, even though I would say what happens in the oxygen lab isn't relevant to the crane so much, but between seats and cranes, we do try to cross-train people. So as people take vacations and whatnot, we can keep the whole shop working. More and more we're transitioning from traditional paper to at least PDF drawings, if not virtual models, so that all of our shop uses tablets now to walk around when they're building things. They have a tablet with the drawing and usually a visual work instruction, so it's like building an IKEA set kind of thing. It's the goal. So it's getting very technology focused. We're transitioning even farther now to model-based definition, where everything's going to be in 3D. Should be much easier for the operators to use. They can go zoom in, see how the parts are really built, so there's no confusion about. In the old days of a 2D drawing, it was, the hip bone's connected to the leg bone, but you really can't see all those little pieces that go in between that. So try to make it as easy as possible. Again, first-time quality is super critical. We assess ourselves we want a 99% or a less than 1% rejection rate, and usually we're like 99.9. 97% quality, so we want to turn back as few parts as possible. So, a lot of our products, our seating and oxygen systems, they're a lot of times the last option for a pilot or a crew member on what's already a really bad day. If you're pulling that ejection handle, you've had, your aircraft break down, the redundant systems break down, and now you have one option, is just to get out. And that system that you're relying on has to work at that point. So it's the team is really invested in that. There's a lot of pride that comes along with that. And so we tend to have a pretty stable workforce because people buy into that process. Quality control, really critical, as I said, making sure that the parts are right, making sure that all the tolerances are tight. You can see a part like that in the bottom, relatively complex. I can tell you my engineer spent a lot of time doing the analysis to make sure that part will hold up in a crash. So obviously if they miss something by even a couple of thousandths, it could be the difference between a breaking or passing the test, and obviously in the field, keeping someone alive. There's some high-end math skills. One of my head inspector is actually a Carnegie Mellon graduate, because he helps a lot of the guys do some of the inference and design interrogation. So there's a pretty broad range of skill sets from, like I said, a GED all the way up to an engineer by training. There's some statistics that we use to make sure the parts are trending and staying in the tolerance bands. If they start falling out of those tolerance bands, we'll try to figure out why, so we can prevent a quality flow in the future. And we have everything from literally just a ruler all the way up to the machine at the top is what's called a coordinate measuring machine. So it's a big computer, it's a 8-foot by 4-foot big table with a remote robotic arm that can go and inspect things down to a 10,000th of an inch. So we use all those different tools to make sure we're getting good quality parts depending on the kind of part we're inspecting. Technology, as I said, there's a lot of technology that's in manufacturing nowadays, and that's advancing even quicker. So whether it's on the design skills with virtual reality and augmented reality tools to, I'm working with a university that's actually doing, trying to virtually create the seat environment so you can actually go make sure you can reach all the controls in the cabin, make sure you can egress. We're doing 3D scanning, so we're looking at pre and post crash, making sure that we can replicate what that test dummy and test asset look like virtually, so we can compare things at very, very high tolerance. All types of some of the analysis tools I was showing before, where it's truly not just a simulation, it's a digital twin of the physical aspect, physical event. And then these are just some of the cool toys we have. So obviously CNC machines, where the machine, you program it, you put all the drilling tools in, and you close the doors, make sure nothing goes wrong in between, get very high accuracy parts at a fairly high rate. In the middle is one of our 3D printers. We use a lot of additive manufacturing, both in the prototyping and conceptual stage. You know, for customer communication, it's not uncommon for me to print a part, give it to the customer and say, use it, let us know what you think, without us having to go, you know, fly halfway across the country to deliver a part or put something together for them. So it's a huge time saver, allows us to really focus on, you know, engineering isn't necessarily seen as a customer service job, but making sure that the customer is happy, because again, the fact it has to work for them all the time in really tough environments. And that last picture is just a more zoomed out picture of our CMM machine. So a lot of technology, and the technology is growing as the opportunities and you know, the costs come down. Some of these things, like when I was in college, in the dark ages, in 2004, we had a 3D printer, and it was like, that was, after your 4-year degree, you got to 3D print something like this big, right? And it was like, oh, that was the coolest thing ever, and you know, God knows how much that cost back then. And now I have 2 of these machines that I can print out parts that are up to about this big at a very reasonable cost for a small business. So things are changing very rapidly, and we're always trying to stay at the leading edge of that. Just a little shout out to Arkwin. They brought some great parts. They actually brought way more cool parts than I did. So just wanted to kind of contextualize what they work on. So if anybody has any questions about their products, I think they might not be too shy to step up and answer them. But I want to thank you guys for coming, obviously. And that's the end of the presentation. So does anybody have any questions? All right. Yeah.
Let them kind of interview you as well to kind of see where they'd be interested in being. They might not know about all of this stuff.
So, you know, that obviously, again, we're a small business, so our bandwidth is somewhat limited, but I'll say we have partnerships with some local high schools and, you know, do things like hiring fairs. And so we've built relationships with, you know, we're out in Ronkonkoma, so local to us, like Longwood High School is a great program where, let's say you're a rising senior in high school and you're like, college isn't for me, whether I can't afford it, I just don't want to, I'm not a great, you know, student, not everybody's ready to go to college, right? So sometimes it's the opportunity to say, you know what, I want to work in industry first, I want to understand why am I going to college, right? College is very expensive, we can't afford to miss as far as I'm concerned. I mean, so that specific case, we'll have those students come in, they'll interview, we'll kind of give them some exposure, like a couple of weeks in each of the different departments, and then we'll do like a 6-month, once they've kind of figured it out, period. It's not uncommon. I mean, we've moved people in the company. You know, I've had people that started in IT that moved to quality. I've had people that started in IT that moved to production, people that started in inspection, moved to assembly. You know, there's all different, we do try to, the cross-training exists not just across departments, across inside of that department, also across departments. So we try to make sure that, especially with young people, you know, preferences change. You might want to be an engineer, and then you go, you know, I just want to build stuff, right? Or I want to be a machinist or whatever. So we try to. Obviously, it's tough to do that at a large scale, right? So generally, we'll try to plug the skill set that we have a gap in first. But with a young person, we're cognizant of the fact that, again, if you're 18, 19 years old, there's a long ways to go. We have a young man that started with us 2 years ago. He started in the oxygen lab because we needed help with some very kind of, I'll be honest, like low skill type work. And he's worked his way up in the lab, and now he wants to go join the military, and we're kind of supporting him, and whether he wants to be in the reservists and still work part-time with us. He's still trying to figure that out, but he came in with basically no skill set at all. And, you know, the oxygen lab, it's really, really safety critical. It's a lot of those parts are very small, so it's a very detail-oriented job, and he kind of learned his way in there. So we had another young lady, actually, she was working in the lab also. She eventually kind of got her head together, and she's now working for a Fortune 500 company in IT, like totally different than what we started with, but she kind of, with some of the exposure, she figured out what she actually wanted to do. So We try. I mean, it's something that's very important. We're not afraid of hiring people right out of high school because we understand there's just not enough. You know, it's not like in the old days, right? So East West is an older business. We used to be in Farmingdale. We had Republic around the corner from us. We had Grumman down the street. And when they had layoffs, we just go walk and go, you, come to us, right? That doesn't exist anymore. So now you have to make those people. You can't just pick them up off the street. So it's a challenge, but we've kind of leaned into this is what it looks like nowadays, so we have to be as adaptive as possible. Hope that answered the question. Anybody else? Nope.
All right, I'll have it.
Okay.
So you're talking about how accuracy is so important, like 99.9%. And I know, so I have a question about why there's so many recalls for cars. It's a totally different industry, I understand, but I'm just like, okay, I know sometimes it's like the battery. It's not something that the car manufacturer make themselves, but how do they, for them it seems that, I've dealt with a number of recalls that I have to go back and take my car back, and like, why such a stark contrast between different industries?
So I will say there's probably a couple aspects to that. So number one of the things that's really gotten is an interesting trend is if you look at car reliability, right? So my first car was an 87 Monte Carlo with a carburetor, right? And a mechanical distributor. And it was those cars, the expectation was you're going to do a tune-up once a year. You're going to change your spark plugs every 2 years, change your belts, change your, do a full rebuild. That wasn't like an uncommon expectation, where nowadays spark plugs are 100,000 miles. You might change the oil every 10,000 miles, change your air filter every 30,000 miles. So the expectation for reliability has changed drastically. The problem is they've also put a lot of technology into cars that is not nearly as reliable, not nearly as mature. And so one of the biggest things, I'm a car geek also, so you're seeing in recalls or customer complaints isn't actually the hard stuff. It's the software, it's those monitors that, you got to go in 12 menus down, and they realize that's a safety issue. Another piece of it is customer expectations, right? So in design engineering, I have a systems engineer who goes through the requirements of here's how we're going to use it. And it's happened before. One of the seats, this seat, oh, it's just going to get all funny with me now. One of the seats we designed, okay, was called a crew chief seat, and they faced afterwards in the helicopter, and they basically, we were told they were just going to get up and sit in the seat, and then land, sit in it just for landing and takeoff. Well, it turns out, Iraq and Afghanistan, they had a gun, and the gun was just at that door. Well, the gun and the seat were right next to each other, and so the crew member wanted to sit in the seat and man the gun, but you couldn't because the gun would hit him in the chest. And that was a case where, in this case, happy to say, it was the customer missed that requirement to understand how it was actually going to get used in the field. And that's the case, I think, sometimes with some of the car recalls where there's an expectation on the engineer's part of here's how they're going to use it, and the reality is the real world use case is different, and then you're having flaws. Another piece, and I'm not going to, Boeing, we're an 8-time supplier of the year to Boeing, so I'm not going to throw them under the bus, but in commercial products, there's a push to bottom dollar cost, right? So it's not uncommon that I'm aware of, at high volume products, things as little as a couple cents can make the difference between winning a huge contract and losing a huge contract. And I think that puts a lot of pressure on the supplier. And I can say from personal experience, when we bid a job, I'm trying to figure out what does it cost today and what's it going to cost in 2 or 3 years. Well, think of what's happened in the supply chain post-COVID. We had cost increases of 25% that we couldn't pass along to the customer because they'd already locked in pricing for 3 years. So how do you mitigate that? I know what we have to do, and usually it means biting the bullet and hoping that you get a chance to fix it next time. But I know in the commercial market, that piece is tough. And then I think there's people trying to push technology, again, for that the customer wants this, so to deliver that, maybe they're trying to use a material that isn't fully qualified, that isn't as robust as they thought it would be, that maybe the testing just misses. We've had things where we'll go test A through Z and then get not a recall, but a customer complaint from the field going, this isn't holding up like we thought. We said, well, we did all this testing. Like, yeah, but I leave it outside in the rain all the time. Okay, well, I didn't test for that, So those are the kinds of things that sometimes it probably comes from a couple different places.